Okay, guys, this mic doesn't work. It's only for the streaming. So this, I have to hold it. If I forget, if I put it down, remind me, interrupt me. Okay. One thing, anybody knows about Pyth? It's called Pyth, no Pyth. Thank you. Anything anyone knows about Pyth? Good, good. And anyone who doesn't know anything about Pyth? Perfect. Fine. That's my job. Anything knows about oracles? That I believe everybody. Anybody can tell. I'm saying anybody a lot of times. What's an oracle? Just tell me. Shout it. This is not a normal workshop. You guys have to interact. Anything else? That's right. Correct. Off-chain. You want to say anything? Okay.
Like observing the real world, other
Yeah.
ecosystems and accessing them.
It's part of that. Okay. Agree. So combining all three, data provider, off-chain data, bringing it on-chain, oracle, simple. But the difference is, as compared to other oracles, we only deal in prices. You need prices, we give that. Any chain, anywhere. We are working on Ethereum, but we do all chains, all different frameworks that I don't know if they exist right now. So prices means crypto, basic. We'll start with that. Forex, stocks, metals, gold, and all that. So if you're building anything with those prices, you can use Pyth. Meme coins also, but meme coins have low, high liquidity. So let's not talk about them. And we also have, there are two bounties, but we also have random number provider, which is VRF function, bit different. So let it be. Even though you want to build with, you want to use prices, you want random numbers, I'll explain both if time permits. How is it different? First, you have to understand that, which is very crucial for using Pyth. So, in blockchain, let's think about like a database for right now. It's not, people will get angry if I say that. It's like a key value database. So if you want to retrieve something, I want price of Ethereum right now, Ether, sorry. What it would be? Like $3,000, I hope. So I have to go and retrieve that. But somebody has to update that. It can't be on the blockchain. Like you're building on like Arbitrum, you're building on mainnet. Both has to have $3,000 price. Somebody has to update it. And update cost gas. So who is updating it? Guess. In all oracles that you probably have used or heard of, who is updating those prices? So, oracle provider, basically. They are updating the price. But if you're building something, you want to buy something with like 10 ETH. Okay. You don't want to use the price which is like 10 minutes or 15 minutes old. You want right now price, not even 1 minute old price, because prices change. But those oracle providers, any oracle provider can't update the price every second because it's expensive. And they have so many prices. For example, we support 1500 prices. If we start updating 1500 prices on every chain, we don't have money. Nobody has that money to update 1500 data points every millisecond. Prices are valuable. They can be updated every millisecond as well. So that's why we changed some things. So when somebody updates a price, it's called push oracle. They are pushing the data on the chain so that you can use it. Clear? You can ask question anytime. There's no Q&A because I will go long. You can ask anytime. Yep. I used to have some slides, but okay, fine. Because I have seen that slides doesn't help. It's more of if you understand the logic, you can easily implement it. So you understood about what's a push oracle? Oracle provider pushing prices, your contract goes, reads it. Simple as that. Whereas in Pyth, you have to pull the prices. That means we don't update the price. We have something called Pythnet, a decentralized blockchain for us. You can't use it. It's only for us, where we aggregate all the data. And we take data only for first-party providers. No CoinGecko, no CoinMarketCap, no aggregators. We aggregate it. We take it from Charles Schwab or Wintermute or Jane Street. These who actually have market makers or dexes. We take data from that. we aggregate into Pythnet and it stays there. Now you want to open a position, you want a long ETH, and for that you need the right current price. What you do in your transaction, you take the data from the Pythnet at that moment and update the price. So the difference is whenever you want data, you have to pull the data. How? That's another thing. I'll tell you about that. But the difference is whenever you're using a normal Oracle, you just say, give me ETH USD price. They give you ETH USD price with the older price. You can't change that. You say, I want right now, but they can't give you because that's the latest updated. But in our case, you can get price at that moment. At that moment for us is 400 milliseconds. We can't go, like our slot time is 400 milliseconds for now. So you can get off-chain as well as on-chain. So you get it off-chain, you read it there, fine. That's normal. But on-chain, what happens? It's a good question. So when the data comes, you can see what the ETH price would be. But you want to update it on-chain if you want to consume there. So you update it with your transaction object. We have a verification. Our contracts that we have deployed are just verify the data that you have passed. Because you can change the data. You took ETH price 3000 USD, but you can change to 4000 USD before updating the price. It's up to you. But we verify that. We send the digest of that data via wormhole and all the bridges, and we verify it. That's our job. Yes.
I have to have an instruction there update the price, right?
Yes.
That has to go onto the blockchain.
Yes.
That means that on your system you only sit on the next block, and that would mean I can hold it if you can repeat the questions. Yeah.
Okay.
So my question. Does this work?
Yeah, it's
Okay, so the question was this. I mean, if I'm a smart contract, I have to have an instruction that tells me, please update the data. That information has to go on chain, and then you can see it. Your system, if I understand correctly, will see it only on the next block.
Nope.
Okay, so explain
Nope.
to me that part.
Yes. So what will happen? Before that, I just want to clear that everybody's on the same stage. Don't be embarrassed. You can ask questions. I'm here for that. Yeah. Sorry, I'll come to you. I just want to have a same state so that everybody understands.
If I understood your interpretation correctly, is that say I have like a OpenSea like NFT marketplace or any kind of
Yeah.
marketplace, and I rely on some data. Some client comes in and places an order, says I want to buy my version of some wrapped stock,
Yep.
basically, right? And so basically I have this market and I need to get this stock price so I can make this wrap token
Yep.
for my. What this gentleman is saying that if the client executes the transaction at block T, my contract will fetch data from Pyth in the same block. So it's like gonna be like a chain execution. Client
Okay.
calls my contract.
Something similar, yeah.
Or what he wanted to make sure is that does your data come from block +1?
Yeah.
Yeah.
So he asked that if I want to extract something, I have to first update it, and the next one I will verify and give it back to you. It's a very bad model. That doesn't happen. So what happens if you see here? You have to extract data from. We call the service Hermes. We name everything on the Greek gods. So you take the data from Hermes, which will be a array of bytes called price update. Since every update costs money, we have to take money from you. So every update costs only one way. Nothing. I can't even tell that in cents right now. So every update costs one way. You can update 100 prices in one transaction also. So it's a bytes array. You take a price update, a bytes array from Hermes. I'll show you how to do that. Not very complex. Normal API service, nothing else. You take that, you put it into your argument. You get update fee. We calculate how many prices are there in that update. Suppose 10 way. You call this method in your same function that you're calling. You have to do that. I have clearly mentioned in the bounty, sorry to get on a tangent, that you have to pull data. If you just go and say, get price, sorry, no, that's how push Oracle works. Once you update it, it will first check what's the last updated price. For example, Ethereum was updated 10 minutes before, but you give me update data before 10 minus 1, it won't update. It has to be after 10. It will check that it is after 10 and it will update it here only. And then you just go get price. This method is get price no older than. So you can have a limit that I don't want price if it's older than 60 seconds. So you get the price here. So in your same transaction which you want to do, you can have that. Verification happen in the same transaction, not in the next block, not even in the next transaction. Is that clear?
Actually, for me, it's not.
Yeah?
I mean, I'm on a block, right? Suppose I wanted a latency of 1 second, okay?
Yes, latency.
We have a block every 12 seconds. So I'm running my contract to execute. It calls, if I understand correctly, your smart contract, and your smart contract sees that I paid or whatever and sends me the data. But if I understand correctly,
It doesn't send you the data. It updates the state on the blockchain and that reads it. It doesn't give you a callback. It doesn't send you data. So there's a state right now in that where key value pair, on that key Ethereum price is 3000, it updates to 3500, for example, in next block only. You update that 3500, latest one, it gets updated in that state only. And anything you do after that state has already been updated. You consume it. There's no callback, there's no other transaction happening.
but if like when at the start of the block, the price was 3500,
Okay.
and then like my contract executes like at halfway through the block and after 6 seconds, okay? During these 6 seconds, Ethereum is now 35,100, okay? And I ask your smart contract, give me the price of Ethereum. What will I see?
You don't ask the smart contract, you send the price update with the latest timestamp.
So what will I get? I will say at 3,500 or 35,100.
The one, so it's, okay. So what will happen? You send the price update for T seconds.
Yeah.
Right now the price something, you send for T seconds. He sends for T plus 1 seconds before that and he executes it first. You'll get T plus 1 second. Because price, we check the latest timestamp.
Okay, and if I'm the first one who asks for a price?
So your T seconds will be updated. Okay? But he also executes in the same block.
Yeah, no, I'm happy for him that he got a free ride on thing.
Yeah.
But I mean, yeah, but I'm not clear. How did I get the price? But the price I'm getting is still from the previous block, correct?
No. Why? Like, if
Because how did the price? I mean, how did the price the price change that happened from the start of the block get online
so when
on chain?
so whenever a block whenever block executes, they have transactions.
Yeah.
They update the memory on state. It's
Yeah.
not committed. But if your contract is executed before the transaction, it
gotcha.
will take the temporary memory and then it will be your contract execution will change some states, our contract change some states, and it all executed at once.
Cool. That's okay.
Okay. Sorry. If you guys have more questions, like we can go on as many questions. I just want everybody to understand what's a pool oracle. Sorry, give me a second. He asked first. Sorry.
Yeah, just a quick question. You mentioned you can ask for updates for many. You can do like a set and
Yes.
update the same in the set and get it in the set, like 100 tokens at the same time. Okay, cool.
Yeah. Just before that, I'll show that. So if you see this contract, just remember these 3 lines. Get update fee or like price update. This is the main thing that people can't visualize right now. I'll show you. So we have this Hermes. You can use it via WebSocket, normal curl command, API. There's no rate limit. You can use it off-chain as well, but that's not part of the bounty. We really want people to learn what's a pool oracle. I go here. I want prices. So I have some of the pre-filled price feed IDs. Price feed IDs, just remember, it's all same. Even if you're building on Optimism, Abstract, or any EVM chain, it's all same. That doesn't change. So I just add, if asking, I add 3. Just imagine they are different. Okay, I'm just being lazy, to be honest. I can go here, price feed IDs, copy 3, okay? And just execute here. It's so difficult to do like this. If you see this blurb of data, big thing, this is the price update. You copy this And don't remember, there's one issue that everybody will have. Since we know solidity came from C++, so every string has to be started with 0x. So you please add 0x when you put that. The reason we never added here, because this Hermes is used by Solana, Starknet, Aptos, Sui, C, Ton, Fuel. So if I add 0x here, those guys can't, they have to remove things. It's easier to add. So just add 0x when you are sending it to your contract. One small thing. And the price will, if Hermes give you past price, this will return from your contract. So if you see this one, the price is here, confidence interval, the exponents 10 to power minus 8, and the published type. This is latest. So this is how Hermes will look. So this will contain all 3 price updates that I just selected above.
Quick question while we're here. Is there any way to get historical prices off chain?
Yes, okay. We have that. I'll tell you after this workshop because it will go long. I'm sorry, he asked question.
Actually, I either forgot or understood that it was not really even a question. So
Okay.
whatever. I wanted to ask if like more users of the Pythnet mean more efficient use of the Pythnet.
No.
No, right?
No, because prices, there's 1500 price fees that we have
Like roll
that
back.
are updated every 400 millisecond. So nobody can have 1500, 400 millisecond on all the chains. We support 160 chains right now, including testnets.
Is there a lookup table on chain where you have basically for currency for an ERC20 a translation into this ID?
No,
Doesn't exist.
no. That's very hard to maintain. We thought of doing that. It's very hard to maintain on chain. Again, we don't have an on chain registry for that, and on chain registry for price feed ID is ETHUSD with the string. We don't have that. You have to go to this page. Everything is on a bounty. Every specific links I have already mentioned so that you don't have to confuse. This is a price feed IDs page. You can search everything. Just go, don't change this. This is for other chains. Like, give me an example. Like gold. What's gold is XAU or something like that? XAU, am I right? Yeah. You just copy this, put it there in the Hermes, you get the gold price. Latest. Yes.
How do you verify the authenticity of the data? Because can anyone just publish some prices and then update the feeds into the network from any source?
I can tell you the answer. Just want to ask, I have 10 minutes. Do you want to get to random numbers or? Okay, just quickly.
I don't mind.
We have, for every price feed that we have on Pythnet, we have minimum of 15 to 16 publishers out there. Minimum. Total, we have a set of 100 publishers. And we don't just start any price feed. You just say, XYZ meme coin, give me price. We can't do that. It has to be some liquidity, some publishers, authentic that we trust. It all aggregates. And sometimes somebody sends absurd prices. That's why we send confidence interval if you saw that.
Okay.
Okay. And so,
Do you have SOC certification on your data?
sorry?
SOC
Yes.
Yeah, you do.
Yep. I'll confirm that again. But I remember somebody asked the same question way before. So I knew the answer, it is there. Or maybe some other certification. But no, don't trust me. I have to tell you the links and everything. Then only. Okay. I'll answer all the price feed questions. I believe people understood like 70% of what I have said. That's enough for me for now. But I'll be here. Let's go to random numbers. It's a bit different than other random numbers. It will have a callback, which you will like. So, let's go to entropy. It's called entropy. And let's go to documentation home. There was a line. The difference between this and there, like normal random numbers, how can we generate random numbers? Such a big problem, blockchain, all that thing. We figured it out, very small thing. So if you have a random number, and no, you want a random number from me, how we can do that? Like, any idea? Send a request. Okay, but how will we generate a random number, and how will you can authenticate if my random number is actual random? Simple. What we did, we asked you to send a random number first. Anything. Yes, like a seed. Perfect. And we have a hash chain. A hash chain is we take one random number and we hashed it millions times and we stored it. Okay? We take one from there, you give me one, I hash it mine, and you hash it yours. I don't know what's yours now. You give me your hash, I give my hash, and we commit that hash on the chain. I'm just telling the logic. We commit each our random number hash on the chain for now. Next block, we send each other our hashes so that we can verify. So that when you reveal, I know that you already committed a hash, you can't change that. And I can know that you are trustworthy. And then we just combine two hashes, and that's the final random number. That's how the logic works. How will you work on that? Pretty straightforward. Normal callback method, you have already used it somewhere. The reason I'm going through docs, because the navigation, we're working on the navigation of docs so that you see how I'm navigating. Just go here and everything. So you remember when you start, because you're looking at a lot of workshops, you might forget. That's why I'm doing it in front of you. Let me show the whole contract. Okay. So for the random numbers, you pass your random number. You can generate with normal SDK, crypto library, node, anything. You get the default provider. We only have one provider. This is the default. Provider is the one, we call it Fortuna. It has all the random numbers stored and all the hashes and everything. Fee, all that. And you said request with callback. You send your own random number and the provider address you got from there. And you have to implement this callback method in your contract. Very simple, entropy callback. And this will be called by our provider, which will give you the random number and you consume it. It's very straightforward. Three things. You send the random number to our first get the fees, send the random number to a Fortuna, the provider, and we will call you back with the random number, consume it. It's straightforward. A lot of folks in hackathons use random numbers because that's a very common thing. You can use it anywhere. Prices, I can understand it gets difficult because you guys might not need the real-time price feeds, which is our competency. But if you use it, it's amazing. I have still 5 minutes. So before going for Q&A, I'll take 5. Sorry. Before going to Q&A, another thing I have seen in the hackathons nowadays that folks who are using Pyth, since it's a pull oracle, and you know a lot of lending protocols out there, Aave and all that, people fork them. And they don't want to change the contract interface. If you see in a contract interface, it was a payable method because you have to send the fees in native currency. And nobody wants to change things. So you can do one thing. We already have a bot, we call it Price Pusher, which will keep updating the Pyth price of specific feeds on specific chain that you want that. Normal, and you can run in Docker, you can just clone it. It's in price feed scheduled prices. You can see that. That's like you know that I want to invest or like build something with stocks and Pyth is the only answer. And I don't want to let users to pull it, so you can push the prices by yourself as a dApp owner and let users consume it like normal traditional Oracle. Sorry for that. Your question.
The question was on entropy. When you get multiple random numbers at once in the callback, so like let's say I'm doing a raffle,
yeah.
I want it to get 10 numbers.
So get one random number, just hash it with different seeds.
Okay. Yeah.
You save money with that. If you call 10 times, you'll have to pay 10 times. So callback will give you one random number. If you go to our best practices, this is a very general question. Okay, callback have a limit on gas because we are calling it. So there should be a limit. Oh, fuck, sorry. My bad. It's fine in crypto. So yeah, that's why I show. You get the random number. I just put it 5 random words. You hash it. You get 5 more random numbers in the same transaction. Okay. I will be outside. We have a table. It's a very corner table. You can ask as many questions as you want. Thank you.
Thank you.